Ladies and gentlemen, welcome to the presentation on 20 years of STS Library. It's my special pleasure to guide you through the ideas and capabilities of this library modeling complex processes and logistics. My name is Dirk Steinhauer. I am manager of the Bremen branch of Simplan. I am a mechanical engineer with a strong industrial background. More than 20 years I worked at Flensburger Shipyard, almost all of the time dealing with simulation in production and logistics. I joined Simplan in 2016. What will be the content of this presentation? First of all, I'd like to introduce STS Library with a short review on the last 20 years and a look into the philosophy. I will show some highlights of STS Library, the capabilities in different industries. STS Library is used in different application fields, which I will show next, as well as application examples for different industries. Last but not least, I will show the Shipyard PLM demonstrator showing the capabilities of STS Library in the context of shipbuilding. So let me first introduce STS Library. It was in the year 2000 when STS Library was established at Flensburger Shipyard as the Simulation Toolkit Shipbuilding. There had been experiences before at Flensburger Shipyard with simulation, but that was done with another software. Those experiences showed that simulation was extremely interesting for shipyards, but the software was not sufficient. That's why plant simulation was bought in the year 2000, and before the first simulation model was built, a library was established to cover all the requirements in the context of the upcoming projects. Over the years, this software was further developed in different cooperation communities. For example, Simofit, together with colleagues from civil engineering. Simcomar was a research cooperation between different partners in the maritime industries. And several research projects also came along to support the development. In one of those research projects, a strong cooperation between Flensburger Shipyard and Simplan was established. And in the year 2016, administration as well as development was taken over by Simplan to bring it to the market worldwide. STS Library is a simulation tool kit for many different applications, especially for complex production and logistics. It contains tools for material flow modeling, model management, determination of execution strategies, output analysis, and data input and output. So what's the philosophy behind STS Library? As a matter of course, efficient and effective model building and maintenance is the main goal for our challenges in complex production and logistics. Over the years, especially in the research projects, we tried out a lot of different modeling strategies. Whatever came out successful was implemented in STS Library. We also have a large set of sample solutions for typical applications. Often, those sample solutions can be adjusted to the specific requirements of the project. As no company is like the other, especially in specific industries, the individual adjustability of tools is extremely important. We provide a lot of interfaces for user-defined rules and settings, therefore. This all wouldn't have been possible without our cooperative development in different corporations, communities, and research projects. Let me highlight another aspect of STS Library. Often, material flow follows a specific sequence of resources, like in a flow line production. This is, of course, covered by standard simulation tools, and you know it from plant simulation. In other cases, very complex processes take place at a specific place on a specific machine using different resources. So it is required to define the process, which might be in one-off process, in an abstract way, and to run it on a specific set of resources. STS Library enables us to do so and also to combine this approach with the resource-oriented modeling. This slide shows the different application fields of STS Library. Sure, still we have a lot of applications running related to the shipbuilding industries, supporting facility planning or production planning. But more and more applications run in other industries, for example, the construction industry. We have an application in the precast, different projects in woodworking, since we cover all the related conveying specifics in our STS library. Different offshore wind parks were installed in the simulation. And one interesting application field is still the maritime logistics, meaning loading and discharging of ships, as well as analyzing the ship-shore interface and also considering the port logistics. Now I would like to highlight some of the capabilities of STS Library. The structure of STS Library is shown in this slide. We have basic simulation tools, not related to a specific application, but usable in all of the simulation models. We have also groups that have specific simulation tools for steel production, for transport, logistics, material, outfitting, and interior fitting. In addition to this so-called basic library, we do have add-on libraries for specific purposes, for ship logistics on board of ships, port logistics, or offshore wind park installation processes. STS Library contains many simulation tools. Only few can be mentioned here. STS Statistics, for example, is the standardization of statistics for the requirements of one-of-a-kind production processes. STS Statistics is implemented in all of the material flow simulation tools of STS. We also have machine-related simulation tools, just like the portal working machine, which can be a cutting machine or a welding machine or other machines, as well as specific machines used in shipbuilding industries, for example, the profile cutting line. The STS Transport Control, for example, provides a fleet of transporters, can be flexibly used for different kinds of transports. STS Compartment represents a part of a building or a ship to be outfitted and interior fitted. STS Space is one of the core tools of STS Library. Many applications require to consider the shape or the size of an object when it's placed somewhere. It may be placed because it's stored, processed, or assembled. STS Space provides this functionality considering size or geometry of objects. Constraints can be defined as well, such as distances between objects. Parts of the STS space can be defined as areas for special purposes, such as building sites or storage areas. Blocked areas can be determined where no object is to be placed. The allocation of space then is done automatically following selectable rules, such as starting point and direction, and circular search, and many others. Those rules can be assigned individual to each object when it's going to be placed. STS Process Control is another core tool of STS Library. This tool controls several parallel processes taking place at the same place. For example, an assembly hall. These processes can be as complex as the final assembly of a complete ship. The process definition is supported by so-called process patterns to minimize the effort. These process patterns contain the selection of work steps to be carried out, as well as default constraints between those work steps. Each part characteristics can be considered when calculating the process time, using specific process time algorithms. For each work step, the required qualifications can be allocated, which includes the human resources as well as tools. In addition to the default constraints, individual assembly constraints can be defined in a hard way or in a soft way. Also, spatial constraints can be considered to avoid having too many processes in a limited space. In many applications, a crane is an important transport resource. STS Crane provides several different crane types. For example, overhead cranes on up to 3 levels with optional extension booms, gantry cranes having several different gantries, luffing and slowing crane on rails, a building crane, or cranes on a vehicle, just such a mobile crane or an installation ship. The implementation of a crane is done by a method just requesting the destination. Optionally, each transport can be specified in detail, such as coupling gantries for heavy loads, turning items, requesting specific personnel for transport, stacking items, or defining an individual transport path for each transport. Since we have started to use 3D animation in our simulation models in 2006, we follow our own specific approach. We build the simulation models in 2D, and we use specific simulation tools like STS 3D Model Generator. Whenever we want to see the simulation models in 3D, these tools generate the 3D model automatically without any extra work. The benefits are that the modeling is easier in 2D without unnecessary 3D graphics, and in 3D just the process is visualized without unnecessary objects like methods, variables, or tables. Since STS Library was used in so many different application fields, the scope of STS Library was enlarged with every project. Different functional groups were added to the original core of simulation tools. Some of them are shown here. For example, warehouse logistics. A fleet of forklifts is discharging and loading trucks and accessing a storage area. Train traffic was introduced because of the projects in port logistics, so bimodal or trimodal terminals can be simulated as well. Construction sites are modeled using the tools that I mentioned already in a very specific way. And traffic can be managed by rules or by systems of traffic lights. STS Library also provides auxiliary functions to be used in the simulation models. For example, with regard to data management. Table data handling can be supported in terms of filtering, parsing, or searching data. Simulation parameters can be centrally managed. 3D animation can be supported by 3D functions, for example, creating scalable geometries, or also creating animation structures. In large models, the model analysis functions are beneficial, for example, tracking MUs or IDs. Also, we have scheduling functionalities, providing backward scheduling of assembly hierarchies. The models built by using the STS library are used in different application fields. For example, layout planning or production planning and control. The factory layout planning is more or less the classical application field for simulation. Investments can be validated. The strategic developments can be supported, for example, introducing a new technology, changing work organizations, or analyzing work time models. Capacities and bottlenecks can be analyzed in production systems. More and more users of STS libraries use their simulation models to support this production planning and control. In this case, simulation works as a decision support tool continuously used in planning and control. By using it this way, dates and capacities of the plan can be verified in an early phase. Building methods can be validated. The plan can be improved or even optimized using optimizing methods. If something does not happen as planned, the instant reaction can be found using the simulation. For example, if design changes, production disturbances happen, and resources are not available. To use the simulation in production planning and control means to integrate it into the IT infrastructure of the company, because up-to-date information had to be available for the simulation with regard to the design, the plan, the resources available, and actuals from production. The simulation model is synchronized with the real production process. On the left-hand side of this slide, the input data is shown required for using simulation in production planning and control. This input data contains product data, schedule, process data, resource data, and actuals from production. In the simulation model, using this input data, the process runs against the resources. And then there's a lot of different output analysis available, usable in the different tasks of planning and control. Getting the input data into the simulation is usually the biggest challenge in a simulation project or implementing the simulation, especially if it has to be up-to-date data. Technically, it's possible to import data directly from different IT systems of the company. Well, I have never had a project where this was possible. Therefore, a data manager usually is required to import data from the different IT systems, connect the data, format the data, and provide the data for the simulation model. In this respect, STS Library provides STS data management to support the user in data handling. It can import data from different sources, connect, have editors for adding data or changing data, creating scenarios, and also handling and managing process data that may not be contained in the IT systems of the company. This data then is stored in a specific format and can be used directly in the simulation model using STS. Now, let me show you some application examples of STS Library. This application case shows the simulation-based planning and control in a precast plant. Additional simulation tools required for modeling precast facilities were added to STS Library. The simulation is based on the actuals from the production plant, automatically imported to a specific period of time. The simulation is embedded into a complex system architecture to support the planner by different interfaces. A rolling scheduling for weekly planning was implemented, as well as daily control in order to manage disturbances. Also, options were available for simulation-based optimization with regards to sequences and staff assignment. Another application example shows container terminal simulation. There's an add-on library available providing additional functionality for container terminals. And also, of course, basic functionalities of STS Library is used. There are different operation modes for container terminals supported, such as straddle carriers, trucks, or reach stackers. I would like to conclude my presentation by having a look on the Shipyard PLM demonstrator. The Shipyard PLM demonstrator is currently built together with colleagues of Siemens in Hamburg. It's going to show the capabilities of Siemens software and STS Library in the context of shipbuilding. The ship is going to be designed in NX. The engineering is orchestrated in Team Center, and the ship's construction is simulated in plan simulation using STS Library. Let's have a look at the current state of the simulation model. We see a shipyard having a dock assembly hall, some space for outfitting after painting, block assembly hall, painting halls, and in the back we have a section assembly line. One of the sections of the ship is already designed in detail, so we can simulate the production of the section. We can see plates are arriving. We see the welding of plates. the cutting of the plates, the erection of stiffeners, and after all, the section assembly. The build section then is stored outside for further usage. We see the sections are now arriving on a rough level of detail, and the full ship is already designed section-wise. We can see in the block erection hall that the blocks are built, are going to the painting hall. When they are painted, doing outfitting after painting in the dock assembly hall. After the keel is laid, the ship is erected and outfitted in the dock assembly hall. I hope that this presentation could awaken your interest in STS Library and its capabilities. Whenever you have questions or remarks, please don't hesitate to contact me. Thank you for your attention. Take care.